Hello, everyone, and welcome to Orkney International Science Festival online, and of course, this very special Saturday lunch edition. My name is Matt Vidmar, and it is absolute delight to introduce you to a full table of guests. I only wish we actually met in person over some delicious food as the one provided in the Pedal Kirk so often when the festivals were actually happening physically in Kirkwall. And we have very, very packed programs. So actually, there's not that much to say in the introduction apart from welcoming, first of all, Martin Braddock, who will tell us a bit more about life at extreme conditions, both on Earth as well as in space, and astronomy being very close to my heart. I'm particularly looking forward to Martin's talk. And then we have Tristan Cameron-Harper, an amateur photographer and mountaineer who's actually done very interesting expeditions and travels, and I believe he also has some absolutely stunning photos to share with all of us. We are not only looking at beautiful sights on Earth. With us we also have Eric Walker. Eric is going to show us some of the nice things further afield, again close to my heart, out there in the night skies. And finally, this is a lunch, so we'll learn some tips and tricks from Sandy Smith. No, I've missed somebody because I haven't seen their picture on the screen. Apologies for that. We'll definitely learn some exciting things about cheese and how you can accompany it with delicious chutneys from Wendy Barrie. But we're also joined by Sandy Smith, who disappeared somewhere, but I'm sure he will appear again, to give us some instructions as to how to join the Great Molecule Hunt, a very special Orkney Science Festival tradition. But as I said, I've already taken way too much time, and I would like to introduce you directly to all my lunchtime guests. First of all, as I said, Martin. Martin combines career in biopharmaceutical industry with a very active involvement in astronomy. His work in drug discovery and development led to him publishing several papers, and he was elected as the Fellow of Royal Society of Biology in 2012 for an outstanding contribution to science. In astronomy, he has given many presentations across European, Asian, North and South American audiences, and of course, this is not the first time he has joined Orkney International Science Festival. I'm very, very grateful for him joining us yet again. And today, he will speak about the extreme conditions under which life thrives and why we should expect to find it elsewhere in the universe. So without much further ado, over to you, Martin.
Thank you very much, Maciek, and I really appreciate the very kind invitation. And like all of us, I wish we were all together sampling some of Wendy's oatcakes and cheese. So the title of my talk is really to get us thinking a little bit about extremophiles and maybe introduce you to the concept of extremophiles. So what are they, for those of you not familiar with them? Well, they're simply organisms, microorganisms in many cases, that can thrive in niche environments. So they don't just tolerate niche environments, they can thrive in them. And there are many examples, and some examples in the top left of this slide show organisms that can tolerate extremely high temperatures. And likewise, there are organisms that can tolerate extremely low temperatures. We have some examples of bacteria in particular who can concentrate their environments and their local, if you like, their local superclusters into examples of very low pH, and these are the acidophiles. And we also have bacterium who can survive in very high concentrations of alkali, which are called the alkalophiles. And I mentioned a little bit about them concentrating in what we call superclusters. And that's simply because the way that these organisms manage to survive is by being in very small groups. There are some examples of bacteria who can withstand incredible pressures. And there are also examples that can withstand fantastic salt concentrations. And all of these conditions are necessary for their survival. So they don't just tolerate these environments, they actually need these environments to grow. And if you think about that from an evolutionary concept, it's allowed them to survive in an environment that others can't, so it gives them some adaptive advantage. In the top right, this is what we call a tardigrade or a water bear, and it's actually an invertebrate animal, and it's an absolutely fantastic organism. It's virtually indestructible. It can tolerate extremely high doses of radiation. It can tolerate being in the space environment. It can tolerate temperature extremes, and it can withstand actually an impact. Now, when I mean an impact, there was a study conducted earlier this year, in May, where these tardigrades were shown to be able to survive an impact of nearly 1 kilometer per second. So can you imagine bombarding something at 1 kilometer per second and being able to survive it? And that's an example of the tardigrades. Now, in the bottom left-hand panel, this is the International Space Station, and some studies were conducted exposing tardigrades, but also bacterium to the space environment. And as we're all aware, the space environment is extremely hostile, extremely cold, of course, dry, and of course, the organisms are exposed to space radiation, particularly galactic cosmic radiation. And organisms have been able to survive the space environment for up to 3 years, and the tardigrades are one of those examples. Now, this has led to the theory that's been around for many decades, and in fact, first proposed by Svante Arrhenius, the elegant looking person in the middle here, a Swedish Nobel laureate, best known for the Arrhenius theory, for those of you familiar with that. That is it possible that the reason that these organisms can withstand such extremes is because they came from space? And this is what we call the panspermia hypothesis. And you can see in the bottom right-hand panel here an example of what might have happened with organisms having arrived to some extent, perhaps on comets that have bombarded the Earth. And it's not as far-fetched as it sounds, because there are some examples of organisms that can withstand incredible G-forces. So there's a bacterium called Paracoccus denitrificans that can withstand 400,000 times the G-force that we experience on Earth. And there is no environment on Earth that has that G-force. So why would an organism be able to survive that level of gravitational field if it doesn't exist on Earth? And in fact, it's only found in cosmic environments, such as the explosions seen on supernova. So if we go to my next and last slide, please. Extremophiles can actually help mankind. So in addition to there being perhaps a logic that extremophiles may exist elsewhere in the universe simply because they can withstand these extreme environments of radiation or impact or hypergravity, it's quite possible that we can isolate qualities for extremophiles that can help us on Earth. And there are examples of thermophiles, bacteria that can withstand high temperatures, acidophiles, cryophiles, those that can withstand very low temperatures, and halophiles. And the halophiles in particular are interesting because they've produced anti-cancer drug leads for us. And the example that I'll show you on the right-hand side is the chemical structure of the molecule salinosporamide A. So salino derives from the fact that this is a bacteria, or isolated from a bacterium that can withstand high salt concentrations. This is what we call the warhead in medicinal chemistry. This is the active part of the drug that gives it its anti-cancer activity. And it's actually now in a drug that's being progressed through clinical trials called marizomib, not that easy to say. And this is a drug that we wouldn't have found had it not been for the existence of extremophiles. So I'm going to finish in about 30 seconds and hopefully give some chance for questions, and just ask you to think through, why should we have organisms on Earth that can withstand such extreme conditions? when actually in some cases they're no longer found on Earth. So I think we can accept the fact organisms can withstand temperature extremes that we have on Earth. That's part of natural evolution. But why would we have organisms on Earth that can withstand conditions that no longer exist or have never existed? And is that perhaps more evidence for the fact that there must be life surely beyond the Earth if there are these examples that can withstand some extreme conditions? So I'll finish up. Thank you, Maciek. And we do have, I think, perhaps time for a question. But if not, I'll end there. And thank you, everybody. And I hope you found that interesting.
Well, thank you so much, Martin. That was actually super fascinating. And, it's been very interesting because it ties into several themes of this year's festival. We've actually heard from Kenneth Bailey just yesterday, who was working on epidemiology and anti-inflammation and the drugs they're used there for fighting COVID. And I'm just wondering if you see any other avenues for drug discovery or other sort of structural sort of chemical structure discovery that can be gleaned from extremophiles beyond these cancer drugs that are currently already researched.
Yeah, I think there are many examples, and there are some examples perhaps when we think about the immune system as a target for many diseases, some of which of course are cancers, but some of which are immune conditions such as rheumatoid arthritis and ulcerative colitis. So I'm sure there are instances. And I'd just like to also finish up by thanking Mikhailo Yetisuta, who I'm working with at the Caithness Astronomy Group. We're looking to publish this thinking, at least, in the Room the Space Journal over this next month. And I'm very keen to support young scientists. I know Mikhailo is a young member of Caithness Astronomy Group, but aspires to a career in astrophysics. And I think this is a wonderful time for young people to be involved in science of any sort, but particularly astronomy. But it's a good question, Maciek, and I'm absolutely sure that there are applications beyond cancer for many of these extremophiles.
Excellent, thank you. And some of our listeners and viewers have already sort of mentioned potential reasons. One Swain suggested actually that your question you posed, why do we have organisms that withstand conditions that have never actually been known on Earth? Well, I suppose that there is an open question. Could it be just because that's a byproduct of some other factor that's allowed them to thrive, that actually, coincidentally also makes them particularly resistant to, high gravity, high pressure, etc.?
It's a good question, but I think we have to think about perhaps what's the evolutionary advantage that an organism has to almost devote its energy to being able to adapt to conditions that it doesn't need. It's not in the organism's interest, if you like, to evolve biochemical pathways that can make it withstand conditions that it doesn't need to. So I always think of this as we are here in the state that we are because we've adapted to our environment. We're not super adapted, and human beings, for example, with the exception perhaps of one or two of us, aren't really extremely adapted to deep pressures or high altitude, deep depths in oceans at high pressures. It's very rare to be able to find people adapted outside of their normal conditions, because we don't need to spend energy on it as an organism, if you think of human beings as organisms. So it's sort of a little counter to an evolutionary argument, but it's a good question.
So just to wrap up, what would be the most kind of peculiar, unusual place? You've mentioned, the bottom of the sea, the depth of the ocean, tall mountains. Of course, we have, Antarctica, places that are, cast in ice, etc. What would be perhaps the most unusual place that we found extremophiles in, or any particular ones that you find affinity with in your research work?
I think one of the organisms that interests me the most are bacteria that are found at the bottom of oceans that can withstand those high pressures, and yet when they're brought higher up out of the ocean, you would expect them almost to explode, and they don't. They can adapt to that. So those organisms can not only withstand ultra high pressures, but extremely low oxygen tension, because there's very little oxygen in the water at that depth. And those organisms, I think, have to be telling us something about biology of adaptation, but also what can we learn about how perhaps some tumors don't respond to radiotherapy because of their oxygen levels. Is there a way that we can understand their biology that will help us in the treatment of disease for the future? But absolutely fascinating to consider. Any condition that we can think of on Earth, we can find life. And to me, that has to mean that we'll find it in space, maybe on Mars, perhaps, over the next 10 years.
Excellent. Thank you so much, Martin. And there'll be talks about, life from even outer galactic spaces. If anybody's interested, tomorrow night, actually, we'll be speaking about a strange cigar-shaped rock that visited us about a year ago. Well, not visited us, but flew past our solar system just about a year ago. And of course, with lots of speculation of what's doing there, and does it potentially contain trace of life even from outside of our galaxy. But thank you so much, Martin. This is super exciting. As I said earlier on, we are, I think, probably already running late because I'm just so excited about the various topics we have here on offer. But I'll quickly transition over to Tristan, who's talked about sort of exploration, extreme places, unusual places. Now, Tristan knows a bit about very cold places for sure. He was a professional ice hockey player. And has a great love for the outdoors and has been exploring many places around the earth. But currently, he's traveling around Orkney, and he's here to describe some of his travels. And of course, as I promised, I believe there's some really interesting photos that he's also happy to share. So, Tristan, would like to hear more from you and your experience of slightly less extreme places, or perhaps just in a different way.
Hey, Magis, thank you so much for the introduction. I mean, obviously, it's great to be in Orkney. It's always a pleasure. I love the Orcadian vibe, and just being able to explore the island is beautiful. I mean, there's such a mass selection of geology that's on offer, and obviously fossils and whatnot. And right here in the picture, a picture of Brugha Bersay, the ancient Norse settlement, and it's a beautiful place in the northwest part of the mainland island, which you can explore. And definitely someplace I'd recommend just to go for a walk and just to take a walk on the coast, because like I said, the geology is just fascinating, and you can just dive so much more deeper into the unknown aspect of what was there before, how many years it's been thriving, and just who walked those lands. So yeah, just as you can see the slipway right across here, where when the tide's low, you can walk right across, and there's a nice cathedral and a church just in the town Brugha along there. And yeah, like I say, the coastal route is it's stunning. I mean, it's just one of those places you come to Orkney and you just get the fresh breeze coming right off the sea, and it's just, I mean, really energizing for sure. A little bit different from the mountains, but someplace that I definitely gravitate towards. It's got an extreme aspect in its own way, and as you can see, the rock structures, hundreds of thousands of years old there. The water is just blasted against the rocks there, and just kind of, it's just one of those awe moments, And yeah, so just really enjoying what Orkney has to offer. And someplace I definitely recommend exploring. Obviously, all the Orcadians know how special it is here. But yeah, quite a change from the mountains and throughout the world. Right here is on the east of the island is a lovely beehive Ducot, and it's one of really rare structures, I believe, in Orkney. It's the only one in Orkney because a lot of them were built originally rectangular and square shapes. And going there, this is quite active. There's still birds that do live in this area. And it was built in the 1600s, I believe. And it was used for, obviously, racing pigeons, for meat. And it's just a really cool structure because the stone in Orkney, as you can see when you go around the island, the stones is just beautiful in the way the masonry is being involved. It's just out of this world. Here is a chambered cairn, Unston chambered cairn, and like so many, there's a really magical aspect that I've been touching on in Orkney, and all the ancient settlements. Here is also the entrance, and when you're inside the chambered cairn, where all the bodies were found, or the burial chamber, you can see outside, and obviously certain times of the year, the sun would come in, and the equinoxes would, the light and everything would change throughout the year, obviously aligned with the stars, certain parts of the year. So the people back in the day were very much connected to the land and the sky. And it's just beautiful. And what's quite interesting is you go in these areas and there's graffiti, people from the 1800s that wrote on the stone, which is obviously not ideal. But it's quite funny because even back then, they're still big kids, going in and doing graffiti. So it's just really special. And like, again, you can see that the stone structure, it's just beautiful in there altogether. Here is a little bit different. This is from the flight from Kathmandu Airport to Lukla Airport, which is one of the deadliest airports in the world. It sits at about 2,800 meters. So it's about twice the size of Ben Nevis. And the runway is only about less than half a mile long. So it's quite daring. And you can imagine the pilots have to fly this on a daily basis to get into the mountains and land on that small runway. But yeah, the beautiful Himalayas in the distance there is just absolutely captivating. Here is another picture in Nepal when I was hiking actually to Base Camp Everest. I was scouting the mountains for some climbs. In the distance, you can see Amadablam, which is compared to the Matterhorn. And it's a very technical climb, challenging climb. It's not exactly a hike up. You need ice axes and crampons and all the gear. And it's about a month-long expedition. And on the right there, you can see some prayer flags, which is darted all throughout the Himalayas, and obviously sending offerings when the wind blows, like peace and protection. And they have all different meanings. They've got little prayers going on each flag. So it's just really special, and it adds some aspect of the culture. Here, Isle of Skye. This is Blaben on the right, which is known as the Blue Mountain. If everyone's been to Isle of Skye, it's quite an amazing part of Scotland, because obviously, like I said, it's quite comparable to Orkney in the same way. It's got a really diverse amount of geology. It's got fossils from dinosaurs, it's got footprints on offer, and obviously the lochs, and just the landscape is just very, very magical too in its own way. Someplace I definitely recommend anyone wanting to go. Here it was a picture taken I camped up Loch Cruisk, which is in the distance you see the Cuillins, which is the mountain range in Skye, and it's one of the hardest ridgelines in the world to compete or to walk across, because it's very technical and you need to have some experience mountaineering and scrambling and whatnot too. But obviously the Milky Way, you can't really argue that with those pictures when you get the moments like that when you're camping and you wake up in the middle of the night, even though it's very cold, and you just get these amazing moments which really make mountaineering and going camping into remote places that much more special. Here is taking it a little more back to the northwest of Scotland. This is Glencoe. This is me, as you can see, it's a little small person, me looking down Glencoe Valley towards the Three Sisters. As you come into Glencoe itself, this is me approaching Annakeegar, which is about maybe a 4 mile long ridge. And it's quite technical, but anyone that's got experience and wants to give themselves a challenge and there's good at scrambling, I definitely recommend doing the Annakeegar. You're very high and you're exposed about 1,000 meters throughout the whole ridge, up and down. And it's just a really beautiful place to explore, especially when you get a nice clear day. It's just a very magical place. This is from just before lockdown there. I was in Mont Blanc, and this is from the very top of the Mont Blanc peak about 5:30 in the morning with my friend Emeric, who works in the French Alps as a guide, and obviously above the clouds and catching a sunrise, being the first on the mountain. It's a special experience. It was very, very cold, and it was very difficult to get that shot with my drone as my hands were almost freezing. But it was just an amazing experience. Come down to the Chamonix, the town, and have a beer, and then look back on that wonderful experience in the morning. It was a great day out on the hills.
Excellent. Well, thank you so much for this, very much a COVID-19 appropriate sort of journey across the whole of the world, really there, from the peaks of Himalaya to the peaks of French Alps, and then of course to some sites that many of us have actually seen and visited here in Scotland. So one thing that I'd like to sort of ask you perhaps is, Martin just talked about sort of extreme conditions, and you clearly are no stranger to extreme conditions. But what would you say is was the most sort of challenging, and because the difficulties come in different ways, and of course different people of course find different things slightly more or less. I'm sure you're sometimes probably find climbing on Mont Blanc easier than some of the long hikes in the Highlands where you're really so far away from any support. So how do you feel about all of these journeys, and how would you compare your own adaptability perhaps to that of other animals and organisms that strive to survive in such inhospitable environments?
I mean, it's really just about putting yourself into that moment of being and really chasing something that you're really passionate about. For me, I love to be in the mountains, and with being in the mountains, obviously there's a mixed range of flora and fauna involved, and with that way you can learn so much. And obviously with Martin, you can connect with him on a different level about things that he's really attracted to and I'm attracted to, and we can both talk about the same thing. And everyone's got a real attraction to, I believe, these raw places in the world where things are untouched and we want to know more about, and we can learn more about, and we could could teach other people about. And it's just going into the unknown. And really, I mean, it's what you get from it in return is what really is attraction there, and just learning more about what this planet has to offer. So, I mean, there's so many ways I can answer that question, but yeah, just kind of learning from it and just embracing the moment for what it is, and just taking it as it comes, really.
Indeed. Well, as all other amateur astronomers know very well, I mean, you've mentioned waking up in the middle of the night in a very freezing condition, but nonetheless enjoying the night skies. That does require quite a bit of patience and quite a bit of sort of persistence, if you like. So I'll pass on to Eric, who's going to show us some more images of the night skies. That, you know, I'm sure there was some hardship involved getting to capture those, wasn't there, Eric?
Yeah, I'll tell you that that image, Tristan, that you showed there of the Milky Way over the Coolins is just superb. I'm just looking for my presentation to come up. Okay, I'll talk about the gods themselves. And if we go into the next slide, the gods, of course, are in Norse mythology. They formed the firmament. They gave the light, the heaven and the earth, and they drew their swords and they caused fires which sparked in the sky. Some became stationary and some became moving. They had their mythology which described the starry sky with the planets moving about them. Next slide, please. And here are some of the Norse names for some of the planets. I'm not even going to attempt to pronounce them, but you can see that they were basically linked to the gods. Mercury was Odin, Venus was Freya, and Jupiter, which I'm going to talk about today, was Thor. So go on the next slide. Currently, we are in moonless skies, which are ideal. The skies are darkening, they are lengthening, and you can have a look for the planets. Now, Mercury and Venus are not really practical to see. They're too close to the sun. But there are two spectacular sights just now, Jupiter and Saturn. And Jupiter's up and visible from about 9 o'clock at night. It gets highest in the sky about midnight and it sets about 2:30 in the morning. And Saturn, which is also bright, but less bright than Jupiter and more yellow, it's easily visible from about 9 o'clock, highest in the sky about 10 p.m. and it sets just after midnight. So if we go on the next slide. Now, this is a screenshot from a free planetarium bit of software called Stellarium, and there's a link in the YouTube description for you to go and download it for yourself, and you put in the place where you live or observe from, and you will see in 3D what the sky is going to look like at any time that you want. If you look south about 11 p.m, this is for North Ronaldsay, and everybody knows that North Ronaldsay was awarded Dark Sky Island status yesterday. Fantastic. So this is from North Ronaldsay about 11 o'clock at night, and you can see Jupiter is pretty much due south, about 10-15 degrees above the horizon, and Saturn is about 8 to 10 degrees above the horizon. The further south you are, the higher up the sky and the brighter they will appear to be. So go out tonight if you've got clear skies and have a look for these two very distinctly bright dots in the sky, and that's the two planets Jupiter and Saturn. Now, if we go in the next slide, now this is what Saturn would look like through a very large, high-powered astronomical telescope with a camera attached. You will see nothing like that, but that's a beautiful Saturn with its rings. What you will see if you look at it through binoculars is a slightly yellow shape, and it won't look absolutely disc-shaped. It will look slightly elongated. Go on the next slide now. And this is the planet I want you to have a look at. If you have a pair of even low-power binoculars, 8x40s, 10x50s, a bird spotting telescope, that's all you need. Point it at Jupiter, and you will see, you won't see the bands, you won't see the cloud bands on it, but you'll see the distinct disk shape of the planet, and you will see 4 bright dots spanning either side of Jupiter. Now, these dots are the Galilean moons. These are the moons that Galileo first saw through his crude telescope that he built and used to observe this particular planet. The moons are Ganymede, Europa, Io, and Callisto. Now, if we go into the next slide, this is what you'll see tonight. So note the positions of the 4 moons. 3 on the left-hand side as you look at it, 1 on the right. Look onto the next one. This is 24 hours later. Oh, look at that. 2 moons. Flick again the next day. Oh, 4 all on the right-hand side. And the next day and the next day. And you'll see, just flick down, there we go. And you'll see that these dots move. Now, Galileo observed this and he realized that those were moons revolving, orbiting around a planet. And he put forward the hypothesis that, well, if you go on to the next slide, he observed that that the moons were orbiting around Jupiter. Now, this was heresy according to the Catholic Church back in the 1600s, and he got basically hauled up for it. And this view of the universe at the time was banned by the Catholic Church. And in fact, in 1663, poor Galileo was sentenced to effectively permanent house arrest in Genoa. Now, he could have had a worse fate than that. But what I want you guys to do is take your binoculars, take your spotting telescope, and you observe what Galileo observed all those centuries ago. And it's absolutely fascinating, fascinating stuff. If we go on the next slide, which will be my final slide, we're going tomorrow, well, it'll be Monday now, we're going to look at what I've called Vikings in Space, and it's how to locate and observe daily bright satellite passes. And we're going to teach you how to find the International Space Station, which will be passing across the sky in the early morning for the next few days. Anyway, thank you very much for that.
Thank you, Eric, and a fascinating inspiration to look up in the night skies later tonight, as well as join more of astronomy talks over the coming few days. But kind of with these extremes, I think we continue now with a sort of a complete juxtaposition, something extremely small rather than something very, very big out there in the universe. We are delighted to be joined again by Sandy Smith, who has for a number of years set up a most exciting sort of contribution to the Orkney International Science Festival. That is the very famous molecule hunt. And I believe the main question that everybody is wondering about is, where does it start? So where does it start, Sandy?
Thank you for that introduction, Matches. It's actually underway now. It started originally in 2011, and the idea came from Keele University. The chap called Graham Jones at Keele did molecule trails, and it gave me the idea that we could actually have it as a hunt and have people go and look for these things. We've held it every year since then, excuse me, and we have to thank Philip Spiring of Mollymod, because the molecules are built from Mollymod kit, and he offers us a prize every year that we can offer to the effective hunter. We get people to go around the shops, look for those molecules, and we then draw all the correct answers and pick out a winner who'll get their own molecule kit. You don't need to know any chemistry. It's simply involving pattern matching, because you're just looking at a picture of a molecule and then you can see the actual model in the shop window. We have modified events that we can also hold in schools, at both primary and secondary schools, with a slightly different approach, but the same fundamental idea. Next slide, please. I'd like to run a little bit of chemistry past you, though. We've got some examples from this year. There are 20 shops. Many of them sell woolen goods. So from those, I've selected a couple of molecules that are found in wool. Now, wool is actually a protein. It's made up of amino acids. Next slide, please. and it gets its name amino acids. Amine from ammonia, and if you mouse over the ammonia one to highlight it, the other half of it is the ethanoic acid, which is on the right-hand side of the screen. And it's probably better known as vinegar or acetic acid. But the International Union of Pure and Applied Chemistry have got a very formalized way of naming things. So ethanoic acid is the official name. The different atoms are shown in different colors: black for the carbon, blue for the nitrogen, red symbolizes oxygen, and the little small white ones are all the hydrogen atoms. Next slide, please. Now, in an amino acid, here are a couple of examples. One of them is cysteine, and you'll see the acid part at one end and the amine part in the middle. But you'll also notice a yellow one in there, and that's actually sulfur, because in quite a few amino acids, you will actually find sulfur as well as the carbon, nitrogen, and oxygen and hydrogen. The other amino acid we have there is methionine. Now, both of these are amino acids that you'll find in the protein that is in wool. They're very similar at one end, but there is a sort of stretched in the middle in one case. And what you need to do is go around the shops and match up which one you see and identify which shop it's in. Next slide, please. So if you decide to take part, if you visit the Kirkwall Bid website for the list of businesses, it will give you the details of the molecule and an image of each one and a description of where you'd be likely to find it and how it's used. You can then find the entry form and you can download that and then visit the shops and go around and mark off each one as you find it. Or alternatively, if you visit the BID website for the list of businesses, if you're not actually in Kirkwall, you can still do it online. You'll find the molecule details and the entry form, and then you can visit the Facebook page for each of the businesses or their website to view the photo of the molecule that's on display. There are 3 shops that don't have the Facebook page option, but their molecules are displayed on the Kirkwall Bid Facebook page. But you'll find all the links as necessary under Kirkwall Bid. Next slide, please. What I would like to do is thank Graham Jones for providing the resources to allow me to do this. As I mentioned at the start, Philip Spiring for providing the prize, the Kirkwall Bid for the support and assistance, because they've given me no end of support over the years. They were fundamental right at the start in helping to run the first one, particularly the help I got from Ronnie Johnson at that time. And it's been ever so helpful since then. And then the 20 Kirkwall businesses that have been involved. Over the years, these have changed, but we stick at 20 because that's a comfortable number for people to be able to cope with. And I'd also like to thank Orkney International Science Festival for all the support and assistance they've given me over the year, particularly Howie and a lot of his colleagues. And finally, I'd like to thank you for listening to my presentation. And I'm sure there might be a minute left if you've got any question you want to throw in. Matthews?
Hi, Sandy. I'm afraid there isn't a minute left. Because we're already running a little bit over time, I hope our audience is enjoying this as much as we are and will bear with us for just a little bit longer. But without too much further ado, I'll introduce the next speaker, if you don't mind, Sandy. But if there are any questions, of course, please feel free, dear audience, to post them in the Q&A. And we can try and pass this on and also answer them either on the page or some other way. But yeah, so I think, I mean, super fascinating, and hopefully as many people will join this year's hunt as the past iterations, which were also wonderful and very successful, including last year's online version. So well done. And finally, Last but not least, and I'm really getting kind of my mouth is watering. You can't see that very well from where you are, but you know, because of course this is meant to be a lunch, and we have a very special guest. We're delighted to welcome Wendy Barrie, who is a chef and food writer and who produces the Scottish Food Guide. So today's lunch mentioned in the program is all about oatcakes, not outcakes. That's a very different thing. Oatcakes and cheese. And I know Wendy's got some very special advice on making chutneys from foraged food. So that's also kind of ties in with the foraging weekend. So over to you, Wendy, to tell us more about how to make some delicious chutneys.
Thank you. Well, it's lovely to be virtually on Orkney, and I have my Sheila Fleet earrings on just to pay homage to the lovely Orcadians up there. Being the Coo's tail is very appropriate for the one that's on the cheese. And with oatcakes and with cheese, chutney works very beautifully. And just to pause for a second, although I know time's tight on the oatcakes, you're a bit bereft of wheat up there, but you have the lovely bear, you have the oats, you probably have some rye. So crisp breads, oat cakes, you've got Karen doing the lovely sourdough, and she does crisp breads now. These would have been dipped and sopped into the soup. So very nutritious, made en masse when the oven's all stoked up. And most would have a house cow, maybe a house goat, and make their own crowdie. And they wouldn't necessarily use rennet, they could be using the local bacteria. And in Norway, they still use the wild caraway seeds, so they might have spiced up these cheeses, or indeed the oat cakes, as we would spice up our chutneys. And chutneys are delicious with cheese and oat cakes. So I would say forage your berries. So just now we've got some brambles, you might add some elderberry, you might add any of the berries that are around at the moment. Crab apples are a lovely one to give you a little bit of bulk and a bit of acidity to your chutney. And then add some spices. So you might have, just now we've got marjoram, maybe a little bit of juniper. Somebody might even have a few chilies growing in their greenhouse and give it a bit of a kick. But you know, you can really make beautiful chutneys. You've got local vinegar, and then you need, of course, some sugar or some honey, and you can keep them all year. Nice sterile jars, and they'll keep all year. So another thing which is more, well, actually we have them wild here in Fife, so it's not necessarily garden, is gooseberries, which was known as the Nordic lemon. So if you're wanting something tangy, then think about looking out for those kind of wild things in your hedgerows as well. So the list is endless, and never get fixated on one recipe. My chutney, I can guarantee you, is different every year.
Thank you so much. That was extremely succinct and also extremely tasty. I can really, it's getting to the point that we really all need to have some lunch. So thank you so much, Wendy. So as was mentioned throughout this lunch, you know, we'd love to actually enjoy each other's company and some delicious food here on Orkney next year. So this is an open invitation in a sense to try and repeat this as we are. But first of all, I just say a big thank you to all of our speakers and for your wonderful contributions that took us away from life at extreme conditions, from the bottom of the ocean up to tall mountains, over to the stars, and of course, some very beautiful sunsets and star rises as well as we went along, and some inspiration to make your own chutney, as well as after you've had your lunch, go on a molecule scavenger hunt through Kirkwall or indeed online. So with that, I only invite all in our audience to join us for more Orkney International Science Festival events. We have a very packed afternoon. There are Sing Along with Mr. Booms at 2 o'clock. There's the Vintage Larry Rally, which I think is a little bit more of a specific thing. So not everyone will be able to join with that. But at 3 p.m., more stars, a workshop on navigating the night sky. So I'm sure there's many things to find. So if you haven't yet checked this afternoon's program, make sure you do so at the Orkney International Science Festival website. But from all of us for now, I hope you enjoyed our company as much as we have each other's and yours. And we are looking forward to seeing you at the Festival Club tonight at the Real, or indeed tomorrow when we have another in the series of these special lunches. So thank you, everybody, and have a lovely afternoon.